I have a phylogeny of bees, and was pretty much happy with the topology now. I think often I don't consider branch lengths so much. Just to get a nice topology is good enough for considering the size of the scale of some of these. But in this case, we want to have some nice, some accurate branch lengths, which you're not going to get if just using CO1. So it's a species-rich phylogeny, but with branch lengths optimized with just CO1, then you get the internal nodes often near zero length. There's no information for those. So what I'm going to do is going to add a bunch of other markers. I've decided to base this on Cardinal and Danforth 2013, which is a basic data multi-gene matrix, which has also been the foundation for some subsequent first species rich analysis. So these are probably a good choice of markers. So what I want to do is, this is a table of their supplement. I've copied this into a text file, and I want to parse out these are all NCBI accessions. So I want to parse these out of this file and retrieve these from NCBI. So I have 7 columns of markers, 18S, 20S RNA, nuclear genes, nuclear protein coding genes, RNA genes, and other columns, which is largely irrelevant. So I just need these accessions so I can then go and obtain the sequences of these. So here's the text file. The columns are separated by species. I'm not sure these are going to be consistent due to some species within the columns. So what I've decided to parse this is just to take the final several columns. So I have considered the first column of the file, and because these have the family in, so I'm just taking the bee families and ignoring the wasps. So only considering lines starting with these strings, which are bee families, and then from the line then taking the last 1, 2, 3, 4, 5, 6, 7 columns, and this character means end of line. Backslash uppercase S is any character which is not a space. So this should take. So this is the point I'm at now. Now I'm gonna just check each entry and see if it looks like an accession. If not, then print it. So NCBI accessions usually start with A to Z, uppercase, maybe 2 of these, and then 6, followed by about 6 numbers, but this is not always exactly like this. So I'm going to check for this format. A little minor thing for variable name in Perl. This gene name is called 18S, but in Perl you can't start a variable name with a number for whatever reason, although you can have numbers after the start of the variable name. So that's why I put locus beforehand. Now what we'd expect and see, some of these they don't have an accession, they have the word missing, so these will probably pop up. Okay. This is not an accession, but this is an accession, so I'm not got this exactly right. So we have an NCBI accession starts with 2 uppercase letters and has 1, 2, 3, 4, 5, 6 numbers. So what have I put here? Okay, I see I've used the wrong character here. So you specify a character in square brackets and you specify the number of instances of a character in curly braces. So I need to change these. Okay, twice again. Okay, so these are fine. This one looks suspicious, so I think I need to put in a line. So I've parsed the table, parsed all the accessions and sorted them into separate arrays. And here, this is going through a single array, a single gene from that input column. And remember this, there is a limit to, so I'll be using eSearch from the EU utilities to interface with NCBI to get the sequences for these accessions. Now I remember there's a limit in how many entries you put on a single query. I don't remember what the number is. So I'll be printing a series of bash commands limiting the number of queries to a specified number, so that's here. So I'm just putting 10 into each file. Initiate the file number, open a output file handle called bash dot file number, go through all the accessions in the array for that gene, and just append the accession name to a string, and once it gets up to the limit, which is 10, then print the string to the file, close the file handle, then open a new one, increment the file number. So you can see it's goes up to 15, so there'll be about 150 accessions for this gene. So this is partly done. Now I just need to get the right syntax for the writing each command. So here as well we're printing the eSearch command, which is this. So I need to get the list of accessions into here. And I should be, so these, I've just tested it, these should be separated with this character, not the, which I put it here, not the commas. So this is not conducting the command, or it's not running the command here. This is just printing it to a text file where it can be run subsequently. So it's printing to this file handle, this eSearch, searching, in eSearch you specify the database query. Now I've got a single quote, might try / this. And then the variable. Okay, so I'll change this date. to a range within. I'm pretty sure that this data is produced, and then pipes the usearch command into efetch faster format for the output of eSearch, and write to a faster file. Okay, so we've got a series of bash commands, and we've placed all the accessions we parsed into the query field of eSearch. Okay, I don't see any problem here. So let's see if this runs. The name is bash1. So to run if we put bash commands into a text file, then we run it with put the ./ in front of the name of the file. Okay, yeah. Sometimes you need to change the premise, so chmod plus x, and that makes it changes the permissions into an executable file. Try again. Okay, so this is doing something. Yep, expected number of entries. So our output file number 2 should contain these. Let's just check. The third one is okay. Orders unexpected, but it is there. Okay, I don't see a problem here. Then we'll write to sequences.18s. So single / is write to a file newly and delete any what was said previously. So we have two forward arrows, and that should append to that. But that means you need to delete what was there previously. So set the gene name 18s, remove the previous output file if present, and then append to that name. So now we don't need those. Okay, let's try this. We have a set of file full of bash commands for separate genes. I'd actually like to change this name. I'd like to delete all these files prior to running this, but this is not sufficiently unique to remove everything called sequences dot anything. So it's going to change. I think I'm going to change this name to something a bit more unique. A little thing I don't like is having no screen output. So I think I'm going to echo just prints to screen. So echo, print the name of the gene and the anyway, 18S28S. Control F. Search for the faster delimiter for the arrow, and that tells us how many. Got 140 sequences in here. And for 28S, 100. 100 well, more than 100. Okay, I think job's done. This seems to be working. Just some minor things to clean up, and then we've obtained our data sets for this supplementary table, and we will later be aligning these and building a super matrix.